Today we will be doing Cambridge paper 11 from October, November 2020. It will take about an hour and 50 minutes. Let's see if we can do it in less than that. Let's start with question 1. Find the set of values for m for which that equation and the curve with that equation does not meet. Okay, that is your question. So if they're talking about meeting, they're talking about intersecting. So please remember, intersection means you have to set them equal to each other, especially if they are in this form already, where the y is alone. So we're doing this, mx minus 3. You can just set it equal to the curve, and they want it to not meet. Okay, so to not meet, we want to observe point of intersection. So bring everything to one side. Okay, and we want to see where it does not meet. So when you analyze this, just make sure, don't make any sign errors. Bring this over, I'm just checking myself as well. We want to analyze the point of intersection, which means we go into discriminant or nature of roots, which is b squared minus 4ac. And if you want it to not meet, you want this to be smaller than 0, because then this line and the curve will never meet. And then what will happen, just remember, this is A, this is B, this is C. Coefficients only, so don't use x anyway, just what goes with your x. So we use negative m squared, check my bracket usage, A, C, and suddenly this becomes an inequality. Okay, negative squared. Okay, you can type this into your calculator or you can try and work this out. Come on, I can do this, 64. And then difference of squares, I think would be the easiest. Let's just do this. And then just be careful, if this was a normal equation, you could just say m is equal to 8 and m is equal to negative 8, but this is an actual inequality. So I need you to plot it for me on a number line, always approach from the right-hand side, intersect, intersect. If it says smaller than 0, it means where your graph dips below the x-axis. So this is the part that you color in. So then m will actually lie between those 2 points. So m bigger than negative 8, smaller than 8. I know these signs look the same, but you read from your m. So m bigger than negative 8, m smaller than 8. Cool. 1 down. Let's just see how many marks did we get already. Sharing my screen. We got 3 marks. Does not meet. Okay, let's move on. Number 2, the equation of a curve is such. Okay, I'm just going to quickly copy that down. When it's written like that, it means it's already been derived. That's not the curve. You know that y is normally the curve. So if they say dy dx, it means it has already been derived. You'll also see that I'm going to as I copy this down, I'm going to bring that bracket up and make it negative. It passes through. Okay, so we've got a curve, dy dx, and the curve passes through that point. Find the equation of the curve. Just check how I copied this down, if this makes sense. I'm already bringing that bracket up and changing it to negative 2 is just easier to integrate and to derive wherever we need to go with this. But to antiderivative this, basically to get it back to y, we need to integrate. So the rule for integration is you add 1 to the top, okay? So even if it's a bracket, we can do this. You add 1 to the top and then you divide with the new exponent, okay? Then also, if we are integrating, this is almost like reverse chain rule. You times this by 1 over coefficient of x. But in this case, it's not going to make a difference. Okay, so I'm using a little bit of reverse chain rule there. And then I'm going to just integrate that. So plus x squared. So you add 1 to the top and divide. Be careful. You shouldn't let this parts of this be derived and parts of this be integrated. If you started integrating here, also integrate this one, because I've seen a lot of students take this one and then actually derive it. So then say like plus 1. No, be consistent. And also don't forget, plus c, because there might have been a constant that we didn't know about when we were deriving. Also, this coordinate is very useful now. In the original, it wasn't useful because there's an x, there's place for x, but there's no place for your y because it was the derivative. But now we've got space. Now we've got space for the x and the y. You can simplify this a little bit before you sub in, but I mean, the calculator will help you a lot. I'm going to just say plus, sub the 2 plus c. Now this should be very easy, the rest of this. So I'm just going to quickly show you what I want there. Equation of the curve. I'm still going to check the memo. They say we need to get to 4. Okay. Some of these things are very easy. You would have typed calculator. So c is equal to 4. Nice and easy. I hope that made sense. Let's move on. Next question. Question 3, just by the way, we do get a lot of marks for integrating. So that was 4 marks and it didn't feel like we did a lot really. Number 3 is quite tricky. I know with past experience, students do struggle with this one. So let's just read this together. Try and not let the wording get to you. There's a lot of wording. Getting from English into calculus is tricky. So air is being pumped into a balloon in the shape of a sphere so that its volume is increasing at a constant rate. So if I hear volume is increasing at a constant rate, rate always has to do with time. So if I want to write that in terms of calculus, I'm going to say dv over dt. Okay. So the volume is increasing at a constant rate of 50 centimeters cubed per second. Find the rate time, hey? Find the rate at which the radius of the balloon is increasing. So this is actually dr dt, if you think about it. So dr dt is equal to unknown. We're supposed to find that when the radius is 10. Okay, so just I've got here for you, just from the reading, I've got this. dv dt is 50, dr dt unknown, and r is 10. Okay, so what I was thinking of doing, something that we need to know from our formula sheet, is the volume of a sphere. So I'm just going to quickly check formula sheet, Cambridge formula sheet. The very first formula that they actually give you on the formula sheet is 4/3 pi r cubed. That is the volume of a sphere. But remember, if you want to relate all of these different parts, we are going to dip into the chain rule. So we do need to derive this so that everything can be related. So look at how I derive this formula. Deriving is times to the front, so that's just 4 pi, and then subtract 1. Also, we do have 10, okay? We've got 10 as r, so I'm just going to sub it in there, 4 pi 10 squared. So this is 400 pi is dv/dr. Okay, so whenever you have so many variables and you're going to try and solve them, let's use the chain rule. Now, the chain rule is on page 2 of your formula sheet. I know it says dy dx on your formula sheet, but I would prefer the left-hand side to be dv/dr. You'll see the left-hand side will contain everything that does not have a t. On this side then, you will have dv over dt. You'll see that the v's match here, divided then by dr over dt. It still works out, like if you flip this one, like tip and times, the t's will cancel out and left-hand side will equal right-hand side. So make sure when you write down your chain rule that it makes sense. Okay, I'm happy with all of this. Let's just sub in everything that we have. We have dv dt, we have dv/dr. Just check that you're subbing it in the right spot. And we're looking for dr dt. Okay, if you don't like the dividing, you can also see it as 50 over this, because then you can just times it that side. So let's do that. 400 pi times by dr dt equals 50. And then obviously to get dr dt alone, you divide that on the other side again. Let's just do that. So dr over dt equals 50 over 400 pi. So if you do this again, just by the way, a shortcut, you can just always switch those two. Next time, just put that there, sorted. So the final answer, let's just see, I'm not going to type all of this into my calculator. Number 3, I'm looking for 1 over 8 pi or 3 significant figures, hey? Let me just quickly show you the 3 significant figures. The noughts in the beginning don't count. So 1 over 8 pi is what I was looking for there. Okay, nice. Okay, I think that the pace is going well. I hope that you're all still with me. Let's move on to number 4. Keep motivated, hey? Don't get distracted after every question. Stay in the zone. Let's go to question 4. Question 4, okay, tree graphs, not everyone's favorite. In the diagram, the lower curve has y is equal to cos x. Please notice that this is a normal cos graph. Starts on the top, dips down at 90, turns 180. If you guys are struggling with radians, just remember this is 180, this is 360. Don't be put off by the fact that it's in radians. The upper curve shows the result of applying some kind of combination of transformations. Obviously, a lot of transformations. Check my mark allocation there. 3, so I'm thinking lots of transformations. Find, in terms of a cosine function, the equation of the upper curve. So I think plenty has happened. First of all, I do see my period changing because now I'm only making one wave in technically 720 degrees. So maybe we should break this down into different things happening. The first thing that I see is that my period has changed. The period you change right in front of your theta. The value that you put there is actually how many waves you will make in 360. Do you guys think we're making half a wave in 360? So let's just start there. I just want to be writing something down. So I'm going to write down y is equal to cos theta, and then I'm going to just start transforming this thing. We spoke about something happening in front of the theta. So because I only made half a wave in 360, I'm going to do this already. Okay, so the period has changed. The period, by the way, now if they do ask you for period, is going to be 720 degrees to make one full wave, or 4 pi. 4 pi. Also something that I want to show you, let's just go back to the sketchy again. I see that it has basically stretched a bit, which is amplitude change. If you take your highest value minus your lowest value, so in other words, 5 minus 1, 5 minus 1 over 2, that gives you your amplitude. So I think in this case, if I just quickly do that, that gives me a 2. I don't want to make it a negative 2 because it's still following the same normal, like going down first. Check the cos graph goes down first. So I didn't change the direction. You can flip this whole graph and then you have to know that your amplitude is negative. But I think for this one, I just think we should just make it a 2. So that's going to go in front here. That's going to happen here. I don't know if you can see that. Yeah, that part. Okay. I'm going to put a 2 in front there. But I want to stick to the sketch. I think there's more things happening. I think it also moved up because technically if you think of changing the amplitude to a 2, then it shouldn't have started at 5. It should have started here at actual 2. So then we also moved it up. How much did we move it up? I think we moved it 3 units up then. So look at my writing down. Let's just capture all of this. I said that there was an amplitude change of 2, which stretches this whole thing. So it stretches the whole thing. Let me just explain to you. It stretches it like this, right? So 2 up, 2 down. So then that means that the distance between the maximum and the minimum is 4. And then we also spoke about moving up. Now, if you want to move up or a vertical translation, you do it at the back here, plus 3. And I promise you in the memo, it's probably going to say 3 marks, probably no method even. Let's just have a look. For number 4, yes, boom, boom, boom. 3, you can put it in the front or at the back. I prefer at the back. 3, 2, a half. Sorted, sorted, sorted. Okay. Is that all for this one? Yes. Okay, we're on to question 5. This is binomial expansion. You guys are ready for binomial expansion? In this expansion, we have got bracket, let's just copy that down, 2x squared plus a over x to the power 6. They do mention that the coefficients of x to the power 6 and x to the power 3 are equal. Okay, so let's just remember that. Find the value of the non-zero, that just means the answer can't be 0, constant of a. Okay, got everything here that I need. Copied everything down. Let us just break down the binomial expansion. So binomial is not difficult if you have a recipe ready. My recipe starts with the exponent. This exponent, write down all your options that can happen. 6, 4, you don't have to expand all of them, but it basically goes down to 6, 6 at the bottom. Okay, so I just want to make sure that this focuses. Okay, the first thing I want to do is I want to show you how the exponents work. This number, this is basically your first term. He will keep going down in powers, right? So this is basically what will happen with him. While the other exponent will go up in powers, but you actually start with a naught. So this ax should be here to the power naught. You can also look at the bottom number. This ax will be here to the power 1. This ax will be here to the power 2. So it's very easy to expand it if you know this power copies there. This power copies to the other one. Then if you minus these two, you'll get this one. This one is just copy and paste. If you minus these two, you'll get that one. And this is just copy and paste. So it's easy to find this one. You just minus the 2 to get the power. And this one is just copy and paste. But remember, you don't have to expand all of them. Hey, if you know we're looking for an x6, we're looking for an x3, you have to be clever here with your selection though, because the 1 is in the denominator and the 1 is at the top. Remember, if you're raising the power, you're timesing the exponents. So what I think we should do here, this looks like it's going to be x to the power 8, and this is going to be x to the power 2. This is actually perfect. It's going to give me x to the power 6. So I am going to expand this one. The button that we use for this 6 and this 2, you can see my calculator nicely here, Casio FX991ZA, the best one. You just type in 6, shift, divide, which is choose, 6, choose, 2. That gives me 15. That takes care of this start. So I'm going to say 15 times 2 to the power 4 times x to the power 8 times a squared x squared. Okay, let's just not go off page. And then we can work it out. Remember, the calculator is there to help you. Don't go rogue and try and do this in your head unless you want to challenge yourself. I'm not going to do it. I get 240. So I get 240 for the numbers. The exponents are actually great because it's x to the power 8 and x squared. So that's going to give me x to the power 6. And I've got a squared x 6. Sorted. We're also looking for something that will produce an x to the power 3. I'm just guessing it's going to be this one, but let's just check. This is going to be x to the power 6. I'm going to x cubed. And then I think this is going to be the one. So I'm going to expand him. Just do selective expansion. Don't do the whole thing. Let me just show you the button again. 6, choose 3. 20. Okay, so this thing gives me 20 times by 2 to the power 3. X to the power 6. And then remember distribution, hey? So it's going to be a to the power 3 over x to the power 3. Okay. And then calculator, yes, times by. Sure, some of you can do it in your heads. A3x3 Okay, so you see, I did something called selective expansion. I'm not going to do the whole binomial. And then I want to go back to the question. Remember, the question mentioned something about the coefficients being equal. Remember, coefficient is just the number that goes with your x. So I think you will save yourself a lot of effort if you just take what goes with your x here, equate it to what goes with your x there. And then we're supposed to solve this. I think let's just make it naught. Bring this over. I don't really want you to get into the habit of dividing with an a. Rather bring everything over to one side. Common factor. What's the biggest thing I can take out here? I'm just going to take out an a squared for now. I know you can take out more than that, but this is also fine. They did say non-zero answer for a because this a squared is producing zeros, but it's not applicable in this case. And then here I could have taken out a big common factor, but I was just going with the flow. Because now this is going to work out perfectly. 240 divided by 160, 3/2. Yes, 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 yes. Give yourself a pat on the back after every question. Okay, let the endorphins flow. You are doing well, and we are not losing our groove. We are immediately continuing with the next one. Don't get up, don't look up even, stay in the zone. That was for 5A. There's always a hence, and this does get tricky. They say find the coefficient of x6 in this expansion. So just notice that they could have said hence here, because there is some questions that are duplicated. This bracket, for instance, this little bracket is exactly what we've been expanding, this guy, right? Just highlight it. This is what we've been working with, right? Can I just highlight nicely? Okay, so I want us to still use the previous question, and also the mark allocation is just 1. So don't do the whole thing again. Keep what you had in the previous one in mind, and then quickly have a look at how I do this. This new bracket is obviously there. There will be many, many things, but I would especially focus on what I created in the previous question. Remember, there was a 160 a cubed x cubed in the previous one, right? There might have been others as well. I just want to quickly see if I need to consider anything else. There any other x cubes? Because what I can do then is to produce an x cubed. I just need to do selective multiplication this time. So what I mean with selective multiplication is I can multiply this one with this one. But there might be more that might produce another x to the power. Or we're looking for x to the power 6 though. Let's just quickly go back to the question. The question said, oh, x to the power 6. Interesting, interesting. Don't get confused with which one you're looking for. We are looking for x to the power 6. So I'm going to change my plan slightly. Okay, so we need this one, but I'm going to just change my root. I'm going to actually times it here to produce an x to the power 6. And then I might need some of my other creations from the previous one. Check, I also have an x to the power 6 there. So let's bring him into the party. I'm going to just write him here. We also had a 240 a squared x6 from the previous question. So check my selective multiplication. Let's bring in some colors. I'm going to times these two to create x to the power 6. And I'm going to times those two to create x to the power 6. So just ignore my original plan. What are we going to create? Here, if I times them together, I am creating negative 160 a cubed. There I'm creating 240 a squared x6. And please remember, we do have a. Hey? A is 3/2. So let's just sub that in. We've got negative 160, 3/2 cubed. Just going to take the coefficient. And then I'm going to plus 240 a squared, but please substitute your a in squared. And guess what? If you type that into your calculator, You get 0. And I've seen so many students doubt that answer. They go, it can't be 0. It can be 0. Okay, so it was only 1 mark though, so I feel like this shouldn't have taken this long. Just expand the bracket, the second bracket, with selective multiplication, and only focus on the things that will give you x to the power 6. Okay, take a deep breath. I think we're halfway. Eh? What is this? 5. Let's see. We're at 6. Okay, at 6. The pace is not bad. I hope that you're all still fine. Let's see the next one. We've got an equation of a curve with a square root. That's always nice. And they ask, find the coordinates of the point on the curve at which the gradient is 4/3. I hope you know that gradient means derivative. So I'm just going to copy down that curve. As I copy it down, I am going to say to the power of a half. Just check what I'm doing here. I'm already writing it like this just to make my life easier. Okay, so then derivative of the curve is the gradient of the tangent. I don't know if you have that recipe in your head, but this is very important. As soon as you derive it, this is the gradient of your curve. Now I'm going to do something called chain rule, but like chain rule's shortcut. If you derive a constant, fall away. If you derive a bracket, focus on this for me. Times it to the front. So we basically derive the physical bracket. So this physical bracket, I'm deriving that. Sorry, that's a bit skew. So times to the front, subtract 1. Fantastic. But then you also have to times by the derivative of the inside. So if you derive the 25, he's going to be gone. If you derive negative x, it's just going to be -1. That's it. Okay? Let me just make sure if I've got the right curve here. Ooh, you see, I copied incorrectly. There's an x squared. Very sneaky. X squared. So now if I derive the inside, it's actually going to be -2x. Guys, don't let mistakes put you off. Honestly, you see me making mistakes as well. The thing is, correct them as soon as you see them. And start developing an instinct of, oh, okay, there's something missing. So this is my derivative. And on the memo, you'll see there's plenty of marks for deriving correctly. I just want to remind you that they gave you the gradient. So you are sorted with gradient. They gave you, the gradient is 4/3. And everything I'm doing now, I'm going to get marks for. I'm just going to times this to the front. It's going to be -x. 25 minus x squared to the power -1/2. And then we need to just do a little bit of algebra. So what is the easiest thing? Maybe just squaring everything. I'm just checking on the paper. It's 5 marks because this feels like a lot of work. I don't know what's the easiest method. I think you guys will enjoy this method the most. Just dropping it down. Remember, a negative exponent means you need to drop it down. You can do cross multiplying at the moment. You can square everything. You can do LCD, whatever method works for you. I think I'm going to go with this one where I cross multiply. So when you times that there, no more fractions. That there, no more fractions. You can only do it if it's fraction, single term equation. Right. Then what are we going to do? I think the easiest will be, let's isolate this half, make it like this, 3x 4, and then let's square both sides. I think it's a good time to quickly square both sides. So when we do that, I'm going to get rid of this half. So I'm going to go 25 minus x squared equals 9x squared over 16. Okay, and then I'm just going to quickly solve this. So times everything by 16, 25 times 16, I should probably know that, that's 400, minus 16x squared equals 9x squared. And then when I try and solve this, I get 425x squared. I should also know that, divided is 16. So then you square root x equals, It is technically plus minus 4, but you know what? If you sub this back into this step, I think only the positive 4 will work. Let me just quickly check on the memo. This was quite a lot of work for 5 marks. Yeah, oh, it's only the negative that works. So for this question, let us just quickly sub it in and see which one works. Because I do feel like I did create a problem in this step. Just make it bigger. When I squared both sides, because squaring both sides is great, but sometimes you have to go and take your answer and sub it back and see which one works. Because I think if you sub back the positive 4 in here, it's not going to give you left-hand side equals right-hand side. So I am going to be selecting the negative 4 rather. And then to get full marks, they do ask you for coordinates. Just want to show you that. Coordinates, which means I want X and Y. So then you just sub that negative 4 back into X, and then you find your Y. Check there. If you sub it in, you will get 5. Okay, good. That was 6. So that's basically half the paper done, sorted.